This is the answer key for the Unit 10 practice test. I'll go through explanations for why the answers are what they are. So the first one says, which diagram is a net of a square pyramid? In order to have a square pyramid, you would need a square for the base. And so if I look at my options, most of them do have at least one square, but then for your to form the pyramid, you need 4 of those triangles that would kind of connect from each of the sides of the square. So the correct answer there would just be A. Because you need a square and then 4 triangles that would kind of meet up at a common point. For number 2, it says 2 pyramids are congruent. The base area of the first pyramid is 12 centimeters squared and the height is 2 centimeters. Which expression can be used to calculate the volume in cubic centimeters of the second pyramid? So we know that the volume formula would be 1/3 times area of base times height of the prism. Of the pyramid. So we have 12 is the area of the base, because they say that the two pyramids are congruent, so the bases would have to be the same. The height is 2. So 1/3 times 12 times 2 would be 8. Or you're just kind of looking for which one of them has that set up, so it's correct. Answer is B. It says find the volume of the cone. Remember, cone's volume formula has a height. It does not use slant height, not 13. So the first thing you need to do is find that height. This is a Pythagorean triple, or just use Pythagorean theorem if you need to do that to help you find the height. So h is 12. Then the formula for volume of a cone is 1/3 pi r is 5 squared 12. And when you calculate this, you don't want to keep pi in the answer. You want to do 25 times 12 times 1/3, which is really 100 pi. So correct answer is A. For numbers 4 and 5, you're trying to figure out the surface area and the volume, but you're answering which one would be greater for each one. So in terms of the surface area for A, column A, I would find the surface area using the formula 2 pi r squared plus 2 pi r h. And so if I simplify this, it comes out to 168 pi, which is approximately 527.78. I also want to come up with its volume eventually, but that'll be for part 5. I want to compare the surface area of these two and say, is column A greater than column B? Because that's how I'm going to answer this question. So to find the surface area of the pyramid in column B, we have the area of the base, which is a square, so it's just going to be 11 times 11 plus, so you can do either 11 squared or 11 times 11 plus 1/2 perimeter times the slant height. Slant height is 15, as you can see it's labeled, and the perimeter of the base is 11, 11, 11, 11, so that's 44 times 15. And when you calculate that, it comes out to 451. So looking at the two answers here, column A is greater because 527 is more than 451. So correct choice on the first one is A. For number 5, you look at the volumes now. So the volume formula of a cylinder is pi r squared h. So pi 6 squared 8. That would be 288 pi, or if you want a simplified answer, 904.8. And then for the volume of the pyramid, it's 1/3 1/3 area of base times height. Area of the base was again 11 squared, and the height is not your slant height. You need to find this height, because you always do height when you work with the volume. So we have 1/3 of, to find the height here, we do Pythagorean theorem. We have 15. Now this side length here is, so to calculate the height that we're missing for this pyramid, we first need to find the lateral edge, this right here, because once we have that information, then we can use that to help us create another right triangle. So you have to do Pythagorean theorem twice here. For the first one, it's this small right triangle where we know the lateral, the slant height is 15. and then the short leg would be 5.5 because it's half of 11. And then we calculate that. I came out to 16. Once I have that 16, then to find this height, I have to do this distance here would be 5.5 root 2 because it would be half of the diagonal, and since the diagonal would be 11 root 2 because it's a perfect, or it's a special right triangle, you can then cut that in half. So this is pretty complicated to come up with, but eventually once you do Pythagorean theorem one more time, you find out that h is finally 14. So plug that in, and then you find the answer for that. It comes out to 56.28. So that's definitely less than the 904. So again, volume of column A is greater. So that's kind of how we would do that one. I wouldn't worry too much about how many times we did Pythagorean theorem on that to help us come up with it. I would rather give you the lateral edge, because once you have that, then you're just doing half of that plus the do Pythagorean theorem to help you come up with the height. All right, now for number 6, it helps if you can visualize what's being asked. It says 50 kids took a dip in a pool 40 meters long and 20 meters wide. So if I imagine, here's my 40 by 20 rectangle, 40 and 20. And it's, obviously it's a pool, so it's in 3 dimensions. So if you want to imagine kind of extending it out 3-dimensionally. And it says if there's 50 kids and they were in this pool, but each kid had, I don't know why it says man, I should say kid. For every kid is a 4 cubic meter displacement of water. That means I have to take 4 times 50 to get the total displacement of the water, which is 200 cubic meters. And then, since I don't know the height here, this is what I'm looking for, because the volume formula for a prism, because that's what a pool is, would be length times area of base times the height, which is length times width times height. So volume would be 20 times 40 times x. Now, I know x is not the entire height there. It's going to just be the height where the water level is. So let's say the water level is to here, whatever it is, that's going to be your x value. So then this is going to be equal to 200, the displacement that we had, and then you're just solving here by dividing by 800, and you get a decimal for the answer, which is 0.25, but your answer is in meters, and the answer choices are in centimeters, so you want to move the decimal point 2 to the right. So the correct answer there is B, 25 centimeters. Okay, number 7. Says here, a sand pit in the shape of a rectangular prism has a length of 7, width of 5, height of 1.75. So first thing I can do there is use those measurements to get the volume, because it says it's filled to the brim with sand. Joe puts his sand into a second sand pit having the same shape but a larger base. And then he needs that much more sand to fill the extra space. And the heights are the same, but it's saying what are the dimensions. So first of all, here's the volume formula. 7.5 times, 7 times 5 times 1.75. Altogether, that comes out to 61.25 is this volume of the sand pit. That's how much sand he would need to fill it to complete like brim. Then it says, well, what about the second sand pit that has a larger base? If you need 17.5 more sand, we're going to add those two together, so we get 78.75. This is all in cubic feet, so it's still a volume. And if we think about the volume formula for the sand pit, it says if the height of the sand pits is the same, that means the 1.75 doesn't change. So what we have here is, think of like length and width. I don't know what they are, so I'm just going to use x and y for a second, times the 1.75. That would have to equal the 78.75, right? So if I just kind of cross that v out, and I'm trying to solve to get x and y, I would divide by 1.75, so that x and y, which are my length and my width, multiply to get 45, because that's what that simplifies to. So 45 has to be my length and my width, so I would go to my answer choices now, because I don't know what x and y are exactly. I just know they have to multiply to get 45, and so you kind of just eliminate the choices that don't work, and 9 and 5 has to be the correct answer, because 9 times 5 is 45. Right, so that's how we would walk through that one. So number 8, you have a hollow iron pipe. It's 21 centimeters long, and its external diameter is 8 centimeters. If the thickness of the pipe is 1 centimeter and the iron weighs 8 grams per centimeters cubed, then the weight of the pipe is what? So a couple of things here. I would write down the radius, because that's what we're going to use instead, is 4 centimeters. You have the pipe itself, is if it's a pipe, it's a cylinder we're looking at. So it's 21 centimeters long. That means this is 21. The diameter was 8, or I'll just label the radius as 4. And then it says if the thickness of the pipe is 1 centimeter and the iron weighs 8 grams per cubic centimeter per 8 grams per cubic centimeter, then we're trying to come up with its weight. So this is kind of using the concept of density as well. But first, let's just start off with coming up with the volume of the cylinder. So we have pi r squared h, right? So pi 4 squared times 21. That comes out to, if I leave it exact for a second here, 336 pi. But it's a hollow pipe, and so I have to then subtract out the inside part of this, which if it says the thickness of the pipe is 1 centimeter. So of this 4, if I'm imagining that like part of it is hollow, to come up with its radius for the other part, I have to subtract 1 centimeter from the 4. So my radius would actually then be 3. So I want to subtract from this pi 3 squared. Now the 21 is the same because it's the height, it hasn't changed for the cylinder of this pipe. So when I calculate this, it comes out to, as a decimal, 461.58, and remember we're in cubic centimeters. The problem now is my answers are in kilograms. My weight was in 8 grams per centimeter squared, or cubed. So what I can do first is to convert it to grams. I would do 8 grams on the top. Then you can write cubic centimeters on the bottom, because those would cancel. So we're technically multiplying by 8. That would get my answer into grams, and then finally you're just going to move your decimal point 3 spots to the left to get your answer in kilograms. Because you have to know your kilo, centa, and so on to know how to simplify. So this comes out to 3695.67. So when I round it, or this is in grams, when I want to convert this, I move the decimal point till the front there, so it's 3.695. I think it was 4 actually here. So 3.695, which is the correct answer, is B. Alright, number 9 says which diagram cannot be folded to make a cube, and so you kind of just want to try each of the examples out, or think about, well, what should the cube look like in order to be, to make sure it has enough of the squares. So in this one, 1, 2, 3, 4, 5, 6, it has the correct number of, all of these have 6, I believe. Yep. All of them have 6, but if I was to try to fold things together so that it would create a cube, I don't have any parallel bases in order to do that. So that's why the correct answer would be D, because there's no parallel bases to help you connect those to make a cube. Number 10, what shapes do you need to make a hexagonal pyramid? That means the base is a hexagon, which means I need 1 hexagon. Then think about how many triangles you'd need. Each of the sides of the hexagon would have 1 triangle. So here's my hexagon. That means I need 6 triangles along with the 1 hexagon. So that's letter choice A. Not rectangles, that's what D was. Doesn't have any rectangles in a pyramid. The next one says name the polyhedron that can be made from this net. 2 parallel triangles, so that means it's got to be a prism, and specifically a triangular prism. So that's C. The cross-section of a 3D figure is shaped like a circle, which could not be the 3D figure. So if it's circle, the only one that doesn't have circles to it is a pyramid, because there's only polygons present on that one. Number 13 says the slant height of a right circular cone is 10 meters. So here's my cone. When you're just asked to find the lateral surface area, that's the pi RL part of it. You don't want the pi r squared, the circle base, because that's the whole surface area. So to find this out, we just need to know its slant height is 10, the height is 8, but we're not going to even use that. You're just going to do pi r. So to find my radius here, this is where you're using the information given. 10 was this hypotenuse, 8 is the height. I need my r. So then this is another Pythagorean triple. It's a 3, 4, 5 Pythagorean triple, so if it's been doubled. So 3 times 2, 4 times 2, 5 times 2. So r is 6. And then that comes out to 60 pi, which the correct answer then is C. And then the last one, what's the surface area of the right circular cone of a height of 14 centimeters, base radius 7 centimeters to the nearest square centimeter? So think of what this would look like if it's a circular, it's a cone. Again, height is 14. It didn't say the slant height. 7 is the radius. I need to find my slant height. So I already did Pythagorean theorem here, so I'm going to tell you what it was. 15.65 is what you get for L, or the slant height. And then just go right to your surface area formula, which is pi 7 squared, pi r squared, plus pi r, again 7, times the slant height, 15.65. And when you type all that into the calculator, you get 498C. And this is in cubic square centimeters, or centimeters squared. Okay, let's keep going. Number 15 says a roller of diameter 70, which again we always come up with needing the radius, so 35 centimeters. And length of 2 meters is rolling on the ground. So if it's a roller, you're looking at a cylinder, and the area that's covered in the roller if you do 50 revolutions. So we have 2 pi 0.35 times 50. So if it's a cylinder, we need to use the cylinder formula, 2 pi r h, and then we also have to multiply by the number of revolutions, so that's 50. But there is a conversion you have to do here, because that's in centimeters, your length is in meters, and so you want to convert to 0.35 meters, or your radius. So again, it's 2 pi 0.35 times the 50 revolutions times the 2 for your height, because think about what the cylinder would look like. That all comes out to 220 is the correct answer for that. Okay, on to the next one, the cargo space of a box. So a box would be a prism. You have 5.6, 4.2, and 3.8. How many cubic feet of cargo space does this box have? So this one is as simple as just multiplying all of those numbers together, because those are your length, width, and height. So it comes out to A, 89.376. Number 17, what's the volume of the cubic feet of a washing machine whose interior is 2.5 feet tall, 3 feet wide, and 2.5 feet deep? So again, this one is as simple as just multiplying each of those numbers together. It's a prism, so length times width times height, or area of base times the height, comes out to 26.25 cubic feet. Okay, 18, we have a fish tank, so that's going to be another prism. 4 feet, 2 feet, and 3 feet are the measurements there. How many gallons of water would it take to fill the tank 5/6 full? So what we need to do first is find the volume, then we'll take 5/6 about times that once it's in gallons. And we know the conversion is a cubic foot is almost 7.5 gallons. So 4 times 2 times 3 gives me 24 cubic feet. I want to convert it to gallons, and so there are, like it said, 7.5 gallons in 1 cubic foot. So I'm multiplying these because I want to cancel my cubic feet. I want to figure out the answer in gallons. That comes out to 180 gallons that I would need to fill the complete fish tank, but I don't want to fill it all the way to the top because the fish have to go in, so I'm going to multiply that by 5/6, and that comes out to 150 gallons. So if you notice, the wrong answer is also sitting there. That A can't be the correct answer because that's not 5/6 of it. That's just the full volume. Okay, number 19. it says here a spherical fishbowl, so sphere, and the diameter is 20, that means the radius would be 10. It says to fill the fishbowl 2/3 full, about how many cubic centimeters of water would you need? So volume formula for a sphere, 4/3 pi 10 cubed. That's how much water we'll need, which comes out to, but then we are going to actually multiply this answer because we don't want to fill it all the way. So it was 4,188.29, but then I'm multiplying by 2/3. So again, wrong answer C is sitting there. Don't grab that one. I need to multiply it by 2/3 to get 2,793 cubic centimeters. Okay, 20, a scoop of ice cream with the radius of 5 centimeters placed on an ice cream cone with a radius of 4 centimeters and height 15. So is the cone big enough to hold the ice cream if it melts? So imagine what this is. Here's my cone, and then the sphere, right? If the scoop of ice cream has a radius of 5, and it's placed on this ice cream cone that has a radius of 4, then, and the height is 15, we're trying to figure out if the cone is big enough to hold it, if the ice cream melts, if it can fill into this cone. So that would be volume of the cone, which is 1/3 pi 4 squared h, which is 15. If I calculate that, and I calculate the volume of just the sphere, which is 4/3 pi 5 cubed, and the two answers I get, so I got 523 for the volume of the sphere, and 20, this was like 281, I think it was, where clearly the cone cannot fit that. So if the ice cream all melted and it would overflow in the cone, because the cone can only hold 281 cubic centimeters versus all of the sphere for the scoop of ice cream. Alright, and the last one here on this page, 66 cubic centimeters of silver is drawn into a wire. A wire would be a cylinder. And then we have so again, lots of units here that we have to be careful with. 66 cubic centimeters, that means that's the volume, has to be equal to the formula for cylinder, which is pi r squared h. We don't know the radius, or yeah, we do, it's 0.5 for the radius, and radius squared, and then it would be height. We don't know what the height is because that's going to be the length of it in meters. So this, once you start solving here, we are dividing by 0.5 squared and by pi. So for the height, I'm just going to jump to the answer, which was 1,403, but that's in centimeters. I want to convert that to meters because the final answer has to be meters, so we divide by 100, or just move the decimal point. So it's about, I'm sorry, this was an 8,403. So that comes out to then 84 meters. So the correct answer is C. Right, next page. So we have a cylindrical vessel, base radius of 14, is filled with water to some height. If a rectangular solid has the following dimensions and immersed in it, will the water rise to? So here's my cylinder, and then I'm going to put a rectangular prism inside of it, which is going to create like water inside of here. So first of all, I can calculate the water amount, or the solid that's in there, the prism. 22 by 7 by 5 comes out to 770. That's going to be the water displacement because that's how much the water would rise, and so that's got to equal, 770 equals the volume of the cylinder, which is pi r is 14, and the height we don't know. That's what we're trying to figure out, what's the water rise. And so when you solve this, you get 1.25, just dividing by 14 squared pi. So that's C. 23 says the volume of a cone is equal to that of a sphere. So volume of the cone is 1/3 pi r squared h, but the sphere's volume is 4/3 pi r cubed. And so if the two are equivalent, we're just going to set them equal to each other. It says if the diameter of the base of the cone is equal to the diameter of the sphere, that means they both have the same r. What's the ratio of the height of the cone to the diameter of the sphere? So you want to just solve for h in terms of r when you do this, which can be tricky with all the fractions, but let's start solving here. So first of all, I'm just going to cancel my pi's right away. Then for my r's, if r squared is here and r cubed is here, I'm going to have just one r left over if I was to divide by r squared. So I'm looking at now 1/3 h equals 4/3 r. And so I want to get rid of I want to get h alone, so I multiply by 3. So now I have h equals 4r. That's the relationship, that the height of the cone is 4 times the radius. But if the question was asking about diameter, we know 4 times the radius is really 2 diameters. So then the ratio would then be 2 to 1, because it says the height of the cone, that's going to be the greater one, to the diameter of the sphere. So 2 times as much. 24 is semicircular thin sheet of metal, and it's open, it's being turned into a cone. So first of all, it's half of a circle, right, semicircle, so 1/2 of 2 pi r, or, because its circumference is what we're dealing with here, because we are going to eventually get to the volume, but that's just starting with the circumference here to come up with the radius, or circumference. So this would be 14 is the radius, or you can just do 28 times 1/2, which would be 14, I'm sorry, we need to come up with our radius. So this is equal to 14 pi. Right, so 1/2 of 2 pi r, which is equal to circumference. Circumference here is 14 pi because of the radius being 28. So obviously your radius would then be 7. Is kind of the way to walk through this. So once I know my radius, I can go to the cone formula for volume, which is 1/3 pi 7 squared, and the h we know here would be, let's calculate what that would be, because looking at what this cone is, it's 7 for the radius. The slant height here is 14, and so the way to come up with why that's the case is think about this semicircle. If this is 14, and I'm cutting, it says you're bending it into an open cone, so you're kind of like doing something like this, where you have the 14, you have this part here is this part of the circumference that we did use, so that's the triangle we're going to work with, and that's why we have 14 here, and then that would be 7√3 because it's a special right triangle. You can use that to do it, or Pythagorean theorem. So that's my height, and then when you simplify this, it comes out to, is a simplified answer, 343√3, or pi can go in front or after it, and then divide by 3. So that correct answer is B. Alright, on to 25. Inner and outer radii of a 7-meter long hollow iron right circular cylindrical pipe are 2 centimeters and 4 centimeters respectively. And then we have we want to find the weight of the pipe. So this is one where you can use the density to kind of help here. But first of all, let's start off with, here's my diagram. Here's my cylinder. And that's for like the hollow, it's hollow, so I need to draw a circle inside of it, and like the cylinder inside. Then we have, the measurements are 7 meters, but if you notice later, all the measurements are in centimeters. So I'm going to actually write this as 700 centimeters, because then I have 2 and 4 centimeters for the inner and outer radius. So inner, it says, is 2, and then the outer, like all the way to here, would be 4. So to come up with the how we're going to walk through this, so we'll do 4 squared pi times the height, which it told me was 700, right? And then subtract from that this inner, 2 squared pi times 700. That comes out to, actually I don't know if I have an answer for that, but regardless, whatever answer you get for this, we need to still multiply this to convert it because the answer choices are in kilograms, whereas my answer is in cubic centimeters, but it tells me how many cubic centimeters are in 5 kilograms. So the answer I get here times, which is in cubic centimeters, I want to put 1,000 cubic centimeters in the denominator, 5 kilograms on the numerator, and multiply by 5, but divide by 1,000 at the same time. So that this comes out to, final answer was 132 kilograms. Okay, here's the next one, 26. What's the number of wax balls, each radius 1 centimeter, which can be made out of a sphere, has a radius of 8? So first of all, the volume of the sphere would be 4/3 pi 8 cubed, which comes out to 2,144.66. Then from there, you want to make more spheres, but they each have a radius of 1 centimeter. So 4/3 pi 1 cubed comes out to 4.1888. So all you have to do to finish this up then is divide the two, because that's how you're going to find out how many you're dividing the big number with the little one, and you get 512 when you do that, roughly. And so you're rounding to 512. And the last one, a hollow sphere of internal external diameters 4 and 8 centimeters is melted into a cone. But the first thing you want to start with then is volume. Formula for the sphere, 4/3 pi. The 8 is going to be the spheres that we're going to start with here, because we're going to start with the outer and then subtract the 4/3 pi 4 cubed. And then we have, once you get to that measurement, you want to then convert to the cone. So this came out to 1,876.6. We want to then use the cone formula to find our height. 1/3 pi, r was 4, squared h. And h is what we're looking for, setting it equal to the answer we just got. You want to multiply by 3, divide by 16 pi, or you can kind of do this in different steps, but as long as you're solving for h here, that comes out to, so also multiply by 3. And final answer for h comes out to approximately 14. So the correct choice is B. A box with inside measurements 60, 30, and 24, so it's another prism, is full of wooden cubes of the same size. If the number of cubes is 25, then the side in centimeters of each cube is what? So first of all, find the volume of those 3 sides, which comes out to 43,200 if you just multiply these numbers together. And that's in cubic centimeters. If I have 25 cubes, and I know that, so I would divide, first of all, this by 25 to figure out how much is each cube's volume, and that comes out to 1,728, and that's got to be equal to, if I think about the sides here for my cube formula number is just s times s times s, which is s cubed. And so to solve here, to find one side length, I would cube root it. On a calculator, that's under math, if you have a graphing calculator, and number 4 gives you that cube root button, and the final answer here comes out to approximately 12. So 12 should be the side lengths, 12 centimeters. Alright, number 29, the surface area of a sphere is 616 square centimeters. If its radius is changed so that the area gets reduced by 75%, then the radius becomes what? So surface area formula is 4 pi r squared for a sphere. That's equal to 616. You want to solve for r. So just to save time here, I'm going to go right to what r was equal to. Divide by 4 pi and square root it, so it's 7. And then from there, we know that if it's 75%, so if I multiply this by 75%, or 0.75, I get 154. That would be equal to my new surface area, 4 pi r squared. And when I solve for r here, I have to divide by 4 pi and square root it, so it comes out to the square root of 12.25. And let me see what that was real quick. .5. So then this correct answer is D. Okay, on to 30. A cylindrical tank 7 meters in diameter contains water to the depth of 4 meters. What's the total area of the wet surface? So think of the formula for a cylinder for surface area. Pi 3.5 squared would be, because the radius is 3.5, and then plus 2 pi r h. H is 4. So just type all of that into the calculator. It comes out to B, 126.5. To 31. So it says the circumference of the base of a right cylinder is 44 centimeters, height is 15, and we want to find the volume. So first of all, if the circumference is 44, think of the formula 2 pi r, divide by 2 and by pi, and you find out that r is 7 approximately. Then go to volume formula for the cylinder, which is pi 7 squared h, 15. So typing that into the calculator, it comes out to 2,310, which is C. Alright, 32, soda is sold in aluminum cans that measure 6 inches in height, 2 inches in diameter, or 1 inch in radius. How many cubic inches of soda are contained in the can? So this is going to be a cylinder. You're just doing volume of the cylinder, pi r squared h. And so that's just 6 pi essentially, and that comes out to 18.8 roughly. Okay, and the last one here, topsoil is sold by the cubic yard. To the nearest cubic yard, how much topsoil is needed to create a flower bed with soil 4 feet wide and 20 feet long by 6 inches? So there's a units that we need to change here. 6 inches is half a foot, right? And we want to keep everything in feet. So because there's 12 inches in a foot. And then to start, we eventually have to convert even to yards. You might not know this, but there's 3 feet in 1 yard. So we'll use that to help us kind of convert as needed. But our final answer has to be in cubic yards. So it's like saying if I want to cube this, because I'm trying to get I'm going to have cubic feet when I'm done, and I want to get to cubic yards, there's 27 cubic feet in 1 cubic yard. So that can help with my conversion. But first of all, I would just do length times width times height, 4 times 25 times a half, which is 50 cubic feet, and then again we're trying to convert it to cubic yards. So if you just divide by 3 cubed, or 27, that's how we get our final answer, which is 2, roughly. That would be 2 cubic yards of soil. Last page here, and the answers are all at the bottom of this anyways, but this gives hopefully a little more explanation. 34 says find the volume of a hemisphere whose radius is 10 feet, and then round to the nearest cubic foot. So hemisphere, well, first of all, sphere formula is 4/3 pi r cubed, where radius is 10, but I want half of that. So I just do times half. That comes out to C, 2,094. A cylinder and a cone each have a radius of 3 and height of 8. What's the ratio of the volume of the cone to the volume of cylinders? Think of the 2 formulas, 1/3, and then the cone would be 3 times as much, right? So the relationship there would be B, 1 to 3. So it's 3 cones fit in 1 cylinder. It's kind of like that video we saw on YouTube that shows the water being poured from one to the other. Okay, last few here. A cylindrical rod of length h is melted and cast into a cone. So we're going to start with the cylinder, and then from there we're going to get to the cone. So where it says the cone's radius is twice that of the cylinder. So if this is r, my radius here is going to be 2r. The height of the cylinder was h, and it says what's the height of the cone. That's what we're looking for. And it doesn't have to be h because we don't know how it's related. So think of the formulas here. If they have this, if it's going from one to the other, they have the exact same volume. So we're going to start with pi r squared h. It's got to equal 1/3 pi 2r squared, and then x for the height. So make sure you square 2r properly. The pi's can cancel. If I have r squared here, and the right hand side, I'm going to get 4r squared. So really I'm looking at 4/3 r squared x. But the r squareds can then cancel. And so my relationship between the h, like when I want to solve for x, not for h, because I'm saying what's the height of a cone, and I call that x. So I want to multiply by 3/4. So 3/4 h is x. So that would be the first one, a, 3h over 4. Alright, a sphere is inscribed in a cubical box. So it's like a cube that the sphere is tangent to all 6 faces. So imagine first you have this cube, and there's a sphere sitting inside of it, so it's like perfectly fitting inside, so that it touches tangent to each side. And it's hard to draw that, but that's the idea. What's the ratio of the volume of the cubic box to the volume of the sphere? So we know volume of a cube, first of all, it's just x cubed, if you think of the dimensions of the cube. Then for the volume of the sphere, I'll just do a circle, 4/3 pi. The radius would then be not x, because diameter is x, it would be x over 2 cubed. And if I simplify this, let's see what it would come out to. 4/3 pi, this would be x cubed over 8 is what you would get there, because you have to cube the 2 as well. And if I just simplify these, then I can get 2. And so I'm looking at pi x cubed over 6, because 3 times 2 gives me 6 on the denominator. And then if I kind of think about setting these equal to each other then, or how I'm relating these two, because it's going to say what's the ratio of the volume of the cubical box, so x cubed, to the volume of the sphere, this pi x cubed over 6. So the x cubes, you can kind of just ignore them. Or, sorry, I lost my x cubed. Oh, sorry, let's, yeah. So I would multiply by 6 here, so that we can kind of move that to the other side. So 6x cubed to pi x cubed just means it's like a 6 to pi ratio. And so that's letter choice B, because the x cubes are just gone on both sides. But I didn't multiply by 6 because it's written that way, it's not divided. It's easier to see with multiplication. Alright, and the last, you can skip 39, so we'll just go to 38, and then we'll stop here. What's the radius of a sphere with a volume of 36 pi cubic yards? And so if that is the volume, you want to set it equal to the volume formula for a sphere, 4/3 pi r cubed. To solve here, you're gonna you are going to divide by 4 pi, or divide or multiply by 3/4. The pi's are gone, and then you're going to cube root it. So times 3/4, and then cube root of r. I don't know if I have that here. Maybe. Let's see. So 36. That comes out to 27, and then you cube root it, and you get 3. So the correct choice is D. Alright, this is where we'll stop for this.